Hi, I'm Long from Rutgers University. Today I want to discuss our paper, Learning View Disentangled Human Pose Representation by Contrastive Cross-View Mutual Information Maximization. Understanding and modeling human poses is a very important problem in computer vision, since it has a wide range of applications in our real world. And a set of 2D key points predicted by pose predictors is a very popular form of representation for human poses, since they have less variation than images, but they are view-dependent. When using 2D poses only for action recognition, we rely on training with action videos captured from different camera configurations. Otherwise, the learned model is vulnerable to the changes of viewpoints, and testing time unseen viewpoints often lead to significant degradations in recognition performance. In this paper, we propose to learn view disentangled representation for human poses by maximizing cross-view mutual information. We denote our approach as CVMIM. The learned representation can be applied to downstream tasks such as single-shot cross-view action recognition. The first objective of CVMIM is to maximize the mutual information between the input 2D pose X and its representation, including pose representation ZP and view representation ZV. Our second term follows the spirit of cross-reconstruction. We define the combination of the view representation ZV and pose representation from another view ZP+ as a cross-view representation of the input. And then we also maximize the mutual information between the input X and its cross-view representation. We then introduce two regularization terms to further improve the results of CVMIM. The first regularization term minimizes the mutual information between the view and pose representations, which ensures they are disentangled. The second regularization term matches the push-forward distribution of representations to a uniform distribution. This ensures the learned representations to be smooth. Please check our paper for more detailed derivations of all the terms here. In our experiments, we trained a proposed CVMIM on human 3.6 million dataset and evaluate on two standard benchmarks for multi-view action recognition, including pan action and NTU RGBD. We start by evaluating our method on pan action under the newly proposed single-shot cross-view setting, where only actions from one views are used in training and actions from all views are used for evaluation. We observe that our approach outperforms other state-of-the-art methods significantly. We also have the same observation on the NTU RGBD dataset, where the proposed CVMIM also achieves the best performance. We continue to experiment on the full supervision setting, where actions from all views are used during training. We can see that CVMIM matches the state-of-the-art in this setting, even yields better performance than models using multiple input modalities. We further investigate model performance when supervised data is limited. We find that our model consistently improves the fully supervised baselines by a notable margin when only a limited number of training samples are available. This shows that the learned pose representations can capture the semantics of 2D poses in a meaningful way, which reduces the amount of supervision needed for the downstream task. At last, we show visual results when using the learned representations of our model for nearest neighbor retrieval. In this figure, we show that our pose representations can successfully find similar poses from different views in the testing set of human 3.6 million dataset. We also show that the learned view representations can retrieve images captured from a viewpoint that is very similar to the query, while the poses are different. Please check our paper for more results. Thank you.